recently been hearing a bit of talk about Encrypted Client Hello, a replacement for the older Encrypted Server Name Indication. Now, before we can get into the meat of what this actually does and how it works, I need to explain some terminology and the way that we currently do things. This is going to be a fairly eagle view explanation. For the networking nerds out there, feel free to add some additional details in the comment section down below. When you make an encrypted connection to a website, when you connect to a website that has properly set up HTTPS, this is going to use the TLS protocol, Transport Layer Security. This is an improvement on an older protocol called SSL, Secure Sockets Layer. Now, in the modern era, you'll often see it referred to as SSL/TLS, and sometimes you'll see projects like OpenSSL, which have been around since before TLS, that never changed their name. This works just fine when you have one IP address associated with one website. But what happens if you have HTTPS x.com, y.com, and z.com all hosted in the exact same place, all with the exact same IP address? Well, due to the fact that the TLS connection, known as a TLS handshake, occurs before the domain is indicated over HTTP, there can be a mismatch over which domain you are trying to connect to, leading to the wrong SSL cert being used. This is obviously not optimal, so to address this, all the way back in 2003, an extension was made called SNI, Server Name Indication. So now, as a part of that TLS handshake, you say, this is the domain I want to connect to, and the problem is completely solved. At least mostly, because now you have this really leaky encrypted protocol. While the content of the website is encrypted, the domain you're going to is in plain text completely unencrypted. And depending on where you are, and depending what site you're trying to access, just going to a certain website might be enough to set off some alarm bells. To address this, Encrypted Server Name Indication, sometimes just called Encrypted SNI or ESNI, was deployed by Cloudflare and implemented by Firefox. What would happen here is you would encrypt your SNI extension using the server you're trying to connect to's public key. You would send the request out, and the server would attempt to decrypt this request using their private key. If this went through, the connection would continue. Now, how would you get that public key? This is the problem. So, it would piggyback off the already existing DNS query you would have to make, the domain name service query. The problem is now the domain name is being leaked in another location. So, to make this at all feasible and worth our time, you also need to have DNS over HTTPS, where we encrypt our DNS queries in the same fashion that we encrypt our website connections. And in their write-up about Encrypted Client Hello, Cloudflare has this to say about ESNI. While ESNI took a significant step forward, it falls short of our goal of achieving full handshake encryption. Apart from being incomplete, it only protects SNI. It is vulnerable to a handful of sophisticated attacks, which, while hard to pull off, point to theoretical weaknesses in the protocol's design that need to be addressed. ESNI was deployed by Cloudflare and enabled by Firefox on an opt-in basis. In 2018, it experienced laid bare some of the challenges with relying on DNS for key distribution. Cloudflare rotates its ESNI key every hour in order to minimize the collateral damage in case a key ever gets compromised. So if their private key is ever discovered, then it's only going to be a problem for at max an hour. This can still cause a lot of damage, but it's a lot less damage than once a day or once a week or manually having to reset it. The problem, though, is DNS artifacts are sometimes cached for much longer, the result of which is that there is a decent chance of a client having a stale public key. So public and private keys come in a pair. If that private key is no longer in use, the public key is also no longer going to be in use, but the DNS might still be distributing that public key after the private key has already been rescinded. So out goes ESNI, in comes Encrypted Client Hello, the last puzzle piece to privacy. Now that's a very extravagant and over-the-top title, and also just not at all accurate. But it is certainly a very big piece in the approach that Cloudflare wants to be taking. Okay, here's the deal. when you want to establish a TLS handshake, the first thing that happens is the client hello. The client goes to the server and says, hey, I would like to establish a encrypted connection. If everything is correct, the server says, okay, hello client, let's establish the encrypted connection. And then all of the stuff with the data transfer, all that fun stuff happens after that. The most important thing here is client hello, because this is where the SNI lives. Now, Encrypted Client Hello, also referred to here as ECH, works a little bit differently with that client hello. Now, it splits it into two parts. We have the outer hello and the inner hello. This is what we refer to in the industry as a hack. It's a very expensive hack and a very elegant hack, but it's a hack. Say you want to connect to x.com. Now, considering this is a blog post from Cloudflare, x.com is hosted behind Cloudflare. So when you want to connect to x.com, you first are actually connecting to Cloudflare, and then Cloudflare is sending you out to that website. This is a situation where a bunch of websites are hosted behind the same IP address. So here's what happens. In the client hello outer, this has your unencrypted SNI. This, to the outside, looks like a regular client hello. In here, what we say is, I want to connect to cloudflare.com. Now, inside of the client hello inner, this is your encrypted hello. This is going to be encrypted using the public key not of x.com, but the public key of Cloudflare. So you have this encrypted payload attached to your unencrypted client hello. This will then be sent to cloudflare.com, which would decrypt the inner hello using their private key, and they can see, oh, this isn't actually trying to connect to cloudflare.com, instead it's trying to go to x.com. But if someone is snooping in on this client hello from the outside, they're just going to see, oh, they're trying to connect to cloudflare.com. They will see the encrypted payload, but they'll have no idea where it's supposed to be going. Everybody snooping in is going to be aware that you are going to a website, and that website is on Cloudflare. But as for the website you're actually going to, only you, Cloudflare, or any other CDN that happens to implement this, and the end destination know where you're actually going. Now, fair enough, you may not like Cloudflare or any of the other CDNs out there. I can totally understand that. And you may not like the idea that this is basically the only third party that knows where you're going. But this is still a massive privacy upgrade as opposed to where we are now. Right now, everybody knows what website you're going to. In this situation, a far smaller number of parties know. It's not perfect privacy, but it's a lot better. Now, the thing with ECH is it only works if there is a lot of websites using ECH on that CDN. So, Cloudflare has already enabled ECH for all of their free zones. So if you're using Cloudflare with their free plan, it's already enabled. If you're paying for Cloudflare, all you need to do is apply for the feature, and then over the coming weeks, it will be enabled. This is one of the very rare times where the centralization of the web is actually a good thing. This is a feature that can only work with centralization. So one place it does not help at all is one website, one IP. There's nothing to really encrypted client hello here, because you're going to be saying in the outer, I'm going to this website, and in the inner, I'm going to this website, and if for whatever reason that website is problematic, it doesn't really make anything more private. Like with ESNI, once again, Firefox is basically a poster child for the feature, and Mozilla also put out their own blog post. Say an encrypted hello to a more private internet. Theirs is a lot higher level explanation. That's the entire diagram they have. It's a good enough diagram, but they skip out on some pretty important details and make it sound a lot more powerful than it really is. As for Chrome, they've been working on support since basically this was first being discussed. It's not enabled by default. It can be tested right now, but it's still a bit of time before every single user is going to have it. As such, in the Chromium side, there isn't currently an option to enable it. So Ungoogle Chromium, Brave, things like that currently don't have the feature. but Microsoft went out of their way to add an option into Edge. I don't really know. As for Safari, they'll probably implement it 5 years from now, and Apple will pretend like they made the feature. Now, in case you weren't sure this is going to do anything whatsoever, it's already causing issues with government piracy site blocking. Encrypted Client Hello effectively defeats pirate site blocking. So, if you don't know what websites people are going to, how do you block them? And it turns out a lot of piracy websites, whether that's like manga sites, video streaming sites, are hosted behind Cloudflare. You might think, why would Cloudflare do that? Money. They don't care where the money comes from. They will just take your money. Tests conducted by Torrent Free show that ISP blocking measures in the UK, the Netherlands, and Spain were rendered ineffective. This doesn't apply automatically to all block sites, as the sites must have ECH enabled. We've seen mixed results for the Pirate Bay, perhaps because it has a paid Cloudflare plan, but other pirate sites are easily unblocked. This feature is going to cause a lot of ripple effect problems. I don't really care about the piracy sites, but there is a lot of content out there that legitimately should be blocked by governments. Pick whatever really abhorrent thing. I don't need to list things out. You know exactly what I'm talking about. And content like that, if it is hosted in a place that is using ECH, also now becomes available. Because of Cloudflare's willingness to take basically anybody's money, there have been some Cloudflare lawsuits. And I would not be surprised if because of this, we start seeing a lot more of them, because that's going to be the most effective way to get rid of these websites without going like full authoritarian, locking down the entire internet, locking out things like Cloudflare. Over the next couple of years, I think the internet is going to be a very, very exciting place if you pay attention to the more techie side of it. But let me know your thoughts in the comment section down below. Do you think ECH is a good idea? Do you like the idea of using Cloudflare as an intermediary to hide where you're going from the rest of the world? I would love to know. So if you liked the video, go like the video. And if you really like the video and you want to become one of these amazing people over here, check out the Patreon, Scribes, LiberaPay linked in the description down below. That's going to be it for me, and I can think of worse companies than Cloudflare.
Something like this.